So, example, find the derivative of the function of g of x. So you want to find d dx g of x. So you got to take the derivative of this integral. But when you just have 0 to x and you have the x right there, it's very simply just plug in x. So this part, extremely simple. You just plug in x to t. And the same thing right here. Just plug in x to t.
So the derivative of the integral from 0 to x, just the equation but with x inside?
Yep, for simple ones where it's just like 0 to x. And you only have one variable over here.
Okay.
Now you have from 1 to x fourth. You're going to find the derivative of that. So you substitute u in for x to the fourth. Then you take the derivative in respect to u times the integral of this times the integral of this times derivative of u in respect to x. So du dx is equal, so and so since you let x to the fourth equal u.
Give me 1 second, I'll be right back.
All right.
Okay.
So what I was saying is like when you got to multiply, you got to take the integral of this, and you got to multiply by the derivative of the function, x to the fourth. So the derivative of this is just secant u, or you take the integral from 0 to u, and you get a secant of u minus, or you get secant tangent of u minus secant of 1. But it ends up equaling this after you take the integral. I don't know why they didn't show it. Anyways, you'll integrate this, and then when you take the derivative, it'll get rid of one of your constants. And you end up with this. And then you multiply du dx is the derivative of x to the fourth, so you get secant. And then you plug in your u right here, and you plug in your d du. And that's that. So it's the derivative of this. Pretty much once you get it here, you can plug in your x just like this one, except it's a u, but you had to multiply by the derivative of that, like in chain rule. Is that making sense? Or
yeah, that makes sense.
All right. All right, what's 7? I think that's a t right there. Yeah, it's t plus t cubed.
Okay.
Just off the examples, what do you think?
Just the square root of x plus x to the third?
Yep. Right there. And now what about number 8?
That's just since it's a 1, that doesn't matter, right? It's just ln 1 plus x squared.
Yep.
Okay. Sorry, I need to answer to someone real quick again.
You did.
Okay.
Now number 9.
Is that an S?
Yeah.
And then that would be just the derivative of g to the s is just s minus s squared to the 8th.
Yep.
So the bottom number doesn't matter if
Because
it's
when you
just a
take the
regular.
derivative, when you end up taking the because this wants you to find the derivative of the function. It wants you to find g prime of s. So when you take the derivative of that, that's going to be a constant. So that's going to disappear.
Okay. I know this gets harder because the linearization ones are really hard.
Yeah. And this one's just square root of u over t plus or over u plus 1. Yep. Now, this one told you exactly how to do this problem.
Yeah, when x is on the bottom, you make it negative or change the sign.
Yes. Change the you change the sign, you make it negative or bring out a negative out front, and you have this. So what do you think it would be? The answer, the derivative of this.
Just negative square root of 1 plus secant x.
Yep. See, this doesn't seem hard, does it?
No, not yet.
Same thing. What do you think about number 12?
Negative y to the third.
Yep.
Oh wait, negative y to the third sine y. I didn't see the sign.
Yeah. All right, now try 13.
There it is. I want to say, let's see, ln e to the x times e to the x.
What's the natural log of e to the x?
Oh, 1.
Nope.
Oh, so then it's, no, sorry. Natural log of e to the x.
What does that
X.
equal?
Just x.
Yep, so it equals x times e to the x.
Yeah, x times e to the x. Okay.
See? Right
Yeah.
there. All right, try 14.
X divided by x squared plus 1 times what's square root? The derivative of times the derivative of square root of x. I can't think of what it is right now.
You're right.
Oh, 1 over 2. Yeah.
Yep.
So wait, why doesn't the square root of x squared, why doesn't it cancel out the square part?
This will be x over how can you simplify this?
Wait. Oh, that x to the 2 square root of x.
So when you have same bases, but the exponents are different, when you're dividing them, you subtract the exponents. So if you have x cubed on the top divided by x squared on the bottom, that means 3 minus 2, so the resultant is x.
Oh, so then the top becomes x to the negative 1/2, which is just
X
square.
to the positive 1/2.
Yeah, positive because you only subtract. Okay.
Algebra is going to kill you.
Well, she never went. Did she ever go over that in the beginning? Because test 2 had some of that.
Probably not. Knowing her. Right. We're coming up on all the problems.
Okay.
All right, try 15. These are way easier than what Pearson gave you.
Yeah. 3x plus 2 divided by 1 plus 3x plus 2 cubed times 3.
Mm-hmm. So it'll be 9x plus 6. No. Yeah. And 3 times that over this. I'm going to try this one.
Which one?
This one.
Okay.
16. You need an identity for this one.
An identity. So I can't just put cosine squared x to the 4th?
Actually, yeah, that would work. I'm pretty sure. Because, yeah, well, no, you can't integrate that as is. That's impossible. But what do you think it is?
Just gonna go with what I said, cosine squared x to the 4th
Times.
times 4x to the 3rd.
Let's see. Well, yeah. I guess because you're only taking the derivative, you don't know how to know the integral of that. Huh. All right, try this one.
Sure. Negative square root of x, 10 square root of x times 1 over 2 square root of x.
And the square root of x will cancel.
Oh, yeah, so then it's just 10 square root of x.
Mm-hmm. Negative 1/2 square root of 10x.
Yeah, because 1 over 2. Okay.
Yeah, I forgot that too. Last one.
Negative square root of 1 plus sine squared x times cosine x.
Mm-hmm. I think we were just having a bad day. That's it.
Okay.
They gave us all those problems. I don't know if there's any more for the first part. Here's more of them. Well, no, that's just integrating. Regular integration. Here's one. 2x to 3x. Yeah, these are hard. She hadn't made you do anything with 2 of these, have she?
Triple? No, I don't think so.
You found the derivative where you have like 2x to 3x.
No, she hasn't done that.
But here's how you do it. Break it up.
So, okay, but what applications does this have exactly?
First part?
Yeah.
Not much. No, I haven't used it.
Because it doesn't make too much sense. Like I understand integrals and the other ones like area or like finding specific numbers of a graph or whatever, but this is just replacing how to replace like a variable.
Mm-hmm. You can't have the second without the first. It's one of those kind of things.
Okay.
Yeah, it's kind of annoying. Well, that's it. That's all I can really do. I can't come up with these problems on my own unless you want to pull up the homework and we try to redo that one problem.
Well, that's linearization where half of the equation is one of these things, but they don't do it like this. They do it from 1 to or from 2 to x plus 1 when x equals 1. So stuff like that.
Okay.
They have equations like that where you have to find that weird number. But
no, that's just Pearson. So you see the difference between Webasson and Pearson? Webasson knows what's important.
Yeah.
Pearson's like, let's make these cry.
Yeah, but she likes to pull out specific, or not even specific. She pulls out questions from Pearson a lot. Like the
Yeah.
quiz had the homework question that we struggled on.
So Monday I'm gonna go over related rates.
Okay.
Do a bunch of those problems. You have anything else you want to go over? Like from the whole semester?
I understand how to do it. It's just sometimes the way they set it up, I'm like these steps I get wrong, but that's just on me. I just have to like read the
Other
problem
steps. Oh,
better.
dude, I hate their steps. I had one of those with the ODE today. Oh my god. Dude, it was like an 8-part problem. Like, you just, I'm not even going to talk about it. It was terrible. Actually, you know, well, wait a minute.
I don't mind.
Other people on YouTube are going to see this too.
And if you want, you could stop the recording since we're not doing.
You're right. You are right.